All right, this is gonna be a long video. We're gonna do all the word problems in one video. Just a word of warning, if I mess up, I'm gonna start that problem over again because I don't wanna have to do these videos again. Most important part with the word problem is drawing that picture. So here in number 21, we're looking at a building with a shadow. So draw the building and the shadow, which means the sun is right here. The shadow is 40 feet long, so this is 40, so that's a shadow. And the angle of elevation, so that means the angle from the ground up right there, is 58 degrees, and we're trying to find the height of the building right there. When we look at this triangle, we've got our angle of focus, opposite and adjacent, so this is going to be a tangent problem. I got to set up my formula, or set up my ratio. Tan of 58 degrees is equal to the opposite over the adjacent, which means that we're going to multiply 40 times the tangent of 58, and that will equal the height of the building. I'm going to go over here to my calculator, making sure that I check and make sure that I am in degrees. And now we get to type in 40 times function tangent of 58, and we've got 64.01. We're supposed to find it to the nearest foot, so that's 64 feet. One apostrophe for feet, 2 for inches. Number 22, I'm going to move everything else down so that I've got plenty of room to draw my picture. A forest ranger watches for fire from a lookout tower built on a high hill. So, got this compound height thing going on here. Because we have a hill, and on top of that hill, we have a tower. There's the fire right there. The line of sight is right there. So we've got an angle of 7 degrees, hint, it's an angle of depression. So we want to make sure that we are measuring down 7 degrees right there. And we are wondering, let's see, how far is the fire from the top of the tower? So we're wondering about this green line right here, because that would be the measure of distance from the top of the tower. Now we need to know how tall he is when he is looking around. The tower is 24. The hill is 740. All of that in meters, good. And so we're going to add those together to get 764 meters for that side. Now that we've got our triangle, we can look at it and set up our ratio, angle, opposite, hypotenuse. So we're looking at a sine function. So, sine, there we go, 7 is equal to the opposite, 764, over the hypotenuse, x. Multiply both sides by x, divide by sine. X equals 764 divided by sine 7. Over here, we've got 764 divided by sine 7. And we've got, 6,269 meters, and we're to the nearest meter. So here we are, x equals 6269.0. So we'll just go with that many meters. Again, making sure you look angle of depression versus angle of elevation. You're gonna have very, very, very different pictures. Move everything down. All right. Sorry. 23. Sun's angle of elevation is 42 degrees. Tree casts a shadow. So back to that original problem. We've got our tree there. We've got our sun. I can use colors. We've got our shadow right there. And of course, we've got that angle measuring the angle of elevation that's up from the horizon is 42 degrees. We know how far we are from the, how long the shadow is rather. It's 17 meters. And so now we've got to figure out how tall the tree is. So I'll throw an X there. We've got opposite, adjacent from that angle. So we're going with tangent. I'm going to set up my ratio. Tangent of 42 equals the opposite over the adjacent, multiply by 17 to isolate the variable, and go over to our calculator. 17 tangent 42. 15.3, and we're going to the nearest meter again, so that's 15 meters. All right, flying along. Take a look at this next one. Angle of depression from the top of the tower to point A is 23 degrees. The distance from A to B, the base of the tower, is 80 meters. How tall is the tower? All right, so here's the tower right here. We are sitting on this tower, looking down at a point A, and the point B is the base of the building right there. So we've got this distance from A to B right there. Now, the tricky part here, we don't actually want this triangle because the angle of depression is the angle down. So I need to draw a kind of false horizon right there, and that angle of depression is 23 degrees. People get this problem wrong because they put the 23 in there. That is not the angle of depression. The angle of depression starts at horizontal and goes down. That distance A to B is still going to be right there. And the height of the, wait, hold on. The distance for, oh, no, sorry, 80. The distance from A to B is 80, which means that distance up top is 80 as well. And we're looking for the height of the tower right there. Angle, opposite, adjacent. This is a tangent problem. So we're going to go tangent 23 equals the opposite over the adjacent. Now, before I go on, it is fine to say, okay, so this is 23, this is also 23 because of alternate interior angles. I can get that. And you can use a different triangle. Not a problem. I want to just stick with this just so we don't get confused between that angle of depression and angle of elevation. We'll multiply both sides by 80. And so we end up with 80. Tangent 23. 33.95, nearest meter, we got 34. Sorry, 34 meters. Down to our last two. We've got the classic ladder problem. You're always going to see one of these ladder problems when you're talking trig. Ladder against a brick wall. Foot of the ladder is 6 feet from the wall. The ladder reaches 15 feet. And so what is that angle? Here's the ladder. Here's the wall. And here's the distance from that wall. In these problems, we're always assuming that wall is at a 90-degree angle with the floor, or as close as can be. So we're 6 feet away. The ladder is 15 feet on the wall, so that's going to be this height right here. If the ladder were 15 feet, then that would be that hypotenuse right there. And we want the degree, the angle with the wall. The angle the ladder makes with the wall, that's going to be this angle right here. I'm going to call that theta, which again is like my x for angles. If that's my focus, opposite adjacent, we've got another tangent problem. Tangent seems to be a favorite for word problems. Tangent of theta is equal to opposite, 6 over adjacent, 15. Now to get the theta by itself, we're going to use that inverse tan operation. Inverse tan on both sides gives us theta by itself. And then we've got tan inverse, or arctan, 6 over 15. Over here, function inverse tan 6 over 15, 21.8, and we're finding to the nearest degree, so we're going to call that theta to be 22 degrees. And finally, we've got a fire department. Their longest ladder is 110 feet long. No way I'd be climbing that. Safety regulation says they can use it for rescues up to 100 feet off the ground. All right. So here is the ladder that is 110 feet long. But that building that it's reaching up, we can only go up 100 feet. You can see that that ladder is not going to go 110 feet up, because otherwise it'd be a perpendicular or straight up and down ladder. That'd be scary. And so now, what is the maximum safe angle of elevation for the rescue? So that's going to be this angle down here. Again, I'll use theta for my angle unknown. Opposite hypotenuse, we've got sine. Set up my ratio. Sine of theta. Opposite over hypotenuse. To get theta by itself, we use inverse sine or arc sine. 100 over 110. Plug this into my calculator. Sine inverse, there it is. 100 over 110. And we got 65.3. Let's see. Safe angle of elevation. They didn't tell me where to round it. I'm going to go ahead and round this to 1 decimal place then. Theta equals 65.4 degrees. Again, if it's not specifying where to round, that's okay. The more work you show, the more my ability is to give you credit for that work, because I'm going to know that you're doing the answer the right way. If the problem's with the rounding, that's something that we can address later.